Okay, so you know yourselves, it's 2011, it's paper 2, trigonometry, and this is it's question 5 on paper 2. So your part A, you're given a right angle triangle, sketch it out, 10, 60. If needs be, you could find the other angle in there, but I don't think you'll need to. You're asked to calculate the length of AB correct to 2 decimal places. I'm going to call it X. The first thing I'll do is I'll label the sides that I have or that I'm going to use, so hypotenuse and opposite. Say to myself, what trig ratio links hypotenuse and opposite? SOH, so sine. So the sine of an angle is equal to O over H. So the sine of 60 is equal to X over 10. That means that X is equal to 10 sine 60. You put that into your calculator, you'll get it. Actually, if you're using a newer calculator, you'll get an answer that X is equal to 5 root 3. But you're specifically asked for correct 2 decimal places, so you will be docked 3 marks if you don't change it. Hit the change button, whatever, you will get 8.660 equals to X. You're asked for 2 decimal places. You look at that number, make your call. 8.66. Of course, it's centimeters. On to the part B. 1. You're given a diagram. There are 3 triangles at play. There's the dominant triangle, which would be that one there, and then 2 more triangles are created when that perpendicular is dropped. This is 65 degrees here. You're told this length is 30. It's O, M, N, P. A couple of different, might be worth your while. That's 90. You can of course calculate this top angle up, the angle MOP, but we'll leave it blank just for the moment. Our first job we're asked to do is calculate OP. So for part 1, I'm going to redraw the triangle. I'm going to use the one on the left. 65 X. So this is quite similar to what you did in part A. And this of course is 10 down here. We need that extra piece of information. So opposite, adjacent. What links opposite and adjacent? That's tan. So the tan of theta is equal to O over A. The tan of 65, X over 10. X is equal to 10 tan 65. Into your calculator, X is equal to 21.4. And it's centimeters again. Okay, on to the next part of the question. So the part 2. You're asked a similar diagram, so again I'm just going to sketch it down. Perpendicular, 65, 10. You now know that this length up here is 21.4. That has to go in. O, M, N, and P. And the chances are, whatever you're asked to do, you're probably going to have to work with the other triangle. Maybe, maybe not. So MON, the angle MON, just to trace that out, just to make sure. So MON. So it's this angle in here that they want you to find. Now there are different ways, different ways to look at this. And sometimes you'll have to do this in a question before you'll be able to decide what your approach is going to be. There is the possibility that you could be asked to use what I call the dominant triangle. So that angle up there is what you're looking for. But if you have a look at that triangle, without the perpendicular, you see that you won't have enough information to use the sine rule. So that means that your approach is going to have to be somewhat different. What it means is, well, you'll have to work out this part of the angle and this part of the angle separately. Now, the first bit obviously is easy. It's 180 minus 90 minus 60, 5. we know that that's going to be 25. So the real thing that you're being asked here is, in this right angle triangle, what's that angle? That's the real question. 90, this is 21.4, and this is 30. So you're going to label the triangle hypotenuse. This would be the opposite, which I'm not going to use, and this is the adjacent. What links hypotenuse and adjacent? It's cos. Cos of theta, CAH, adjacent over hypotenuse. So the cos of x, which is the angle I'm looking for, is the adjacent, so 21.4 over 30. X is equal to cos inverse you're going to put that into your calculator. Get quite a long answer. You're going to put it all down. And that's that portion of the angle. But to find the angle, so the angle MON is equal to 25 degrees plus all of this that you've gotten here. But of course, you're asked correct to one decimal place, but just write it all in, add it up, and then reduce it, then round it up or down. That'll keep going. The only bit we're asked to round it up to one decimal place, so it'll be 69.5 degrees. Sorry, just let me get rid of that for you. So that's the part B. On to the part C. So a boat sails due east from a lighthouse from a point A. The A is pointed out to you. It's not a great diagram. It's a little bit difficult to see. You're told that the height of the lighthouse is 30 meters. It goes to the point B, and when they look back basically at the top of the lighthouse, they're looking up at an angle of 68 degrees. Then they sail on a little bit longer for another 10 seconds, I think, and they stop at C. And when they look back up at the lighthouse then, they're looking now at an angle of 33 degrees. And what you're asked to do is, well, if this is B and this is C, you're being asked calculate the distance from B to C. In other words, how far did they travel? Now, again, there are three triangles here. There is a small right angled, there's the dominant right angled, and then there's a scalene in there as well. But I suppose a little bit of experience, and you've seen a question like this before, will tell you that the easiest way to find out what this length here is, x, is to say, well, if I can find out the length from the base, which is A, and I can find out the length AB, well, if I were to subtract the two of those, that would give me what I'm looking for. So really I'm just, oh, that didn't come out at all, did it? Hold on now. So again, so there's AC. So if I can figure out the length AC, and I can figure out the length AB, that then, as I say in there, when I subtract them, that's what I'm looking for in there. So really and truly, you're only dealing with two right angle triangles. Okay? And the two right angle triangles, You're trying to find the base length in both of them. So it's a little bit messy, so I'm just going to redraw them. So in the first triangle, that's the larger one, I'm going to call this x. This is 30, and I know that this angle is 33 degrees here in the long one. I'm going to label everything. Hypotenuse I'm not going to label because I'm not going to use it. This would be the opposite, this would be the adjacent. So what I'm saying is, what links opposite and adjacent? That's tan. So the tan of 33 degrees is equal to O over A. So 30 over x. X is going to equal to 30 over the tan of 33. Now it looks like they're just swapping, but we've talked before about the manipulation that's going on there, so we won't get into it just now. So x is going to equal to again, it's quite long, but you're going to have to put in the full answer. It's 46,195,4,891. It's a little bit tight there, but it'll be okay. Then on your smaller triangle, so I'm just going to redraw it again because it's quite it was messy there. So 30, I'm going to call this x this time again, only now I'll be dealing with an angle of 68 degrees. It'll be the exact same thing, label, it's going to be tan. So the tan of 68 is equal to 30 over x. So that means x is equal to 30 over the tan 68. X is going to equal to 12.12078678. So long enough. Okay lads, I'm just going to start a fresh page. How do you find the distance BC? But basically you just subtract. So two very long answers. So BC, so it's going to be 46.19594,891 minus 12.12078678. Just take me a second to type this in. Your answer there will be 34,075,16213 meters. Okay. Now, you're not asked in the question to round that up or down, so you have to leave your answer like that. Okay. It doesn't say correct to the nearest meter, anything like that. So on to the part 2. Part 2 says calculate the average speed at which the boat is sailing. So the second you see speed in the question, well, speed is equal to distance over time. If you have a look, well, we know how far the boat travelled. And if you double check the question, you actually know how long it took the boat to travel from B to C as well. It says 10 seconds later. So when you divide that in, you'll get that. And of course then you do check it and it says correct to 1 decimal place. What is worth taking a note, it may be the case that the way the question is worded there, it says give your answer No, it doesn't. No, it says give your answer in meters per second, correct to one decimal place. So they're only referring to part 2 of that question. So you wouldn't necessarily go back and round up or down at your answer from part 1. And that's it. That's the question.